Okay guys, and welcome back to my YouTube channel that makes no money. So without further ado, let us talk about integration. So in my class, we've really been focusing for the past 2-3 weeks on, well, let me go to the next page. The past 2-3 weeks we've been focusing on finding the derivative. Finding the derivative. Okay, that process is called differentiation. All right, that's the process of finding the derivative. Big word, differentiation. So that's what we've been doing. And let me just refresh your memory of what the formula is. If I have a function x to the n power, then the derivative of that function n times x to the n minus 1 power. Okay, so whatever this exponent is, you pull it to the front, multiply it by whatever coefficient is here, and where the green is, and then you subtract 1 from the original exponent, and that would be the derivative of that function. Okay, this is called the power rule. There are lots of rules, but I'm only going to focus on the one that will be on the IB exam for you guys. This is called the power rule. Okay, and so it's called a power rule because it is literally talking about functions that have a power or an exponent. So that is what we've been talking about. And so scrolling back up, integration, literally, it's just the reverse process. Okay, so integration is just the reverse process of differentiation. Okay, so in other words, I find the derivative okay, that's differentiation. Integration, I am finding the antiderivative. Alrighty, very important. There is an opposite process for everything. Like every concept in math, there's a reverse process to it. Addition, subtraction, multiplication, division, squaring a number like x to the second power versus, and then that opposite would be the square root, or taking the cube of a number, x to the third power, cube root, right? So there's an opposite to everything, and this is no different. So let's do some examples. So I'm going to give you the formula, and it's kind of going to be ugly looking, but it's really not as complicated as you think it's going to be. Okay, so let's talk about notation. That is so ugly. Let's talk about notation. Okay, so I don't feel like saying find the antiderivative. I don't feel like writing it out every time. So all there's a symbol for that. And this is your symbol. It's like this curvy, like F-looking thing. It's like a, but without the line going through it. One more time, just because I like when they look pretty. Okay, here we go. That's the best I'm going to do. Oh my god, literally. Okay, here we go. Yay! I got it. This is this curvy symbol thingy. This is the integral. This is the integral. It's an operator. It tells you... Okay, it tells you what to do. And it's telling you, when you see this symbol, it's telling you to find the antiderivative. So, say I have a function x squared, and the question is telling me, in regular words, find the antiderivative of the function x squared. What you're going to see is this, attached directly beside the function. Okay, dx, let's talk about dx. So, dx means with respect to. With respect to whatever letter. So in this case, with respect to x. Let me give you another example, like a counter example, just to kind of show you why it is relevant. Say I have a function, and it looks like this: x squared plus 2y, and it tells me to find the antiderivative or to find the integral. Okay, so at this point, there are two variables in this problem. All right, there's x and there's y. dx, this d and then whatever, it tells me what to care about, right? So in this first example, there's only one variable, so obviously it's going to be x. But in this example, in the second example, you have two variables. So now the person who wrote the problem has to specify, do they want you to find the antiderivative with respect to x or with respect to y? So these types of problems, you're actually really not going to see them in this course, like on your IB Math exam. But I do want you to know what this, dx, what it actually means. It just tells you what to care about pretty much, or the relevant variable. And that's more utilized down here, but I just want you to know what this means. Okay, I don't want you to be afraid of it. So let's move on to, so we talked about notation, talked about some symbols, what your problems are going to look like. So now let's discuss the actual formula. So the formula, so if I have a function, f of x, right, which x to the n, then the integral of f of x, which is x to the n, is, okay, here I just replaced it. So the integral, it's going to be 1 over n plus 1 times x to the n plus 1. Okay, that is how you find the antiderivative. And so take a minute, write that down. This is the only formula there's a tiny little piece missing. It's called the generic constant. You're going to see it. You're going to see the letter C in the next couple of weeks. But I don't want you guys to focus on that right now. I really want to stagger this material. It's really not that huge a deal. It's literally just tack it on to every single answer you come up with. But make sure you have this red formula. So if your function looks like this, x to whatever power, then the integral of that function, which happens to be x to the n, right? This is how you find the antiderivative or the integral. Notice I'm using those words interchangeably. So let's do some examples. All right, let's get into it. Exciting. Example 1. So find the antiderivative of x to the 3 with respect to x. All right, so once again, this is not telling you to do anything. It's just talking about which is the relevant variable. The symbol is telling you to find the antiderivative. So, first thing you do, you have that formula in front of you. All right, so our n in this scenario, if you go back, our power is 3. Oops. So very naturally, n plus 1, which is what we're going to be using in this formula heavily, is 4. Okay? All right, this n plus 1, this is now what I care about. This is what I'm going to be using to find my answer. So what I do, I attach the new exponent to the base, to the x, and then you tack on 1 over 4, okay? 1 over whatever your new exponent is. And so that simplifies, really, so that's really 1 over 4. Really, so that is 1 over 4x to the 4th. That is great, but personally, I like to write it like this. And that is my answer. Okay? That's literally it. Like, you just do, this is what I recommend you do. You find your new exponent, attach it, and then your last step, multiply the entire thing by 1 over that new exponent. So let's do another one. Let's do another one. Example 2. Find the integral of x to the 6 with respect to x. So n equals 6, n plus 1 equals 7, right? This is what I care about. So formula 1 over n plus 1 x raised to the new exponent. So just following this formula blueprint, it's really what they are, blueprints. X to the 7th power, tack on 1 over 7. Okay, so your final answer, as simplified as possible, is x to the 7th over 7. Alrighty. And let's do another one. Example 3. now I'm going to introduce visible coefficients, because up here we do have an invisible coefficient, so that's 1. Now I'm going to make these coefficients visible. So let's make it 2x to the 5th power with respect to x. And so same exact process. N equals 5. Your n plus 1 is 6. And so again, that's what we care about. 1 over n plus 1, x to the n plus 1. That's your formula. Alrighty. So it's x to the 6th power. Do not forget this 2, okay? Actually, let me go to the next page. Actually, wait. You know what I can try to do? Let me see if I can try to, like, copy and paste it. No, I want to copy and paste it. Copy. Can I paste it? I got it! Okay, great. I love it. Go back. Oh my god. Can I write? It's not letting me write, guys. Oh, here we go. Alrighty. Let's do a little erasing. Erase. Sorry for the delay. And here we go. Alright, so the formula tells us 1 over 6, right? 2x to the 6. So you never, ever, ever want to ignore the original function, what the actual original function is. The reason this looks a little bit different is because examples 1 and 2, right? See, that's a 1 right there. And that's a 1 right there. So really just, I didn't have to multiply by 1, so I left it. But whenever you have a coefficient in your problem, like 2, 3, -3, -20, whatever, x to whatever, you never want to ignore that. Okay, so you always want to make sure you include it, okay, in your answer. And so let's start simplifying. We're done. The heavy lifting is done. Now we're just going to simplify. So I have 1 over 6, 2 over 1. This is just me just not skipping like any steps. So that's 2 over 6, x to the 6, which reduces to 1 over 3, x to the 6, which can be rewritten like that. Okay, so that's the whole problem, top to bottom. Okay, so let's do another one of these where there's a coefficient. Example 4. Let's find the antiderivative of 4x to the 11th with respect to dx. And so, same process. Right now, n is 11, so n plus 1 naturally is 12. So there's your formula. 1 over n plus 1 x, whatever the function is, x to the n plus 1. Alrighty, so let's do this. N plus 1 is 12. So writing it out completely, make sure you have all the parts. 1 over 12, 4, x to the 12th. Okay, now we just have to simplify. So 1 over 12, put the 4 in fraction form. Okay, that reduces to 4 over 12, x to the 12th, which reduces to 1 over 3, x to the 12th, which can be rewritten as x to the 12th over 3. It's actually hideous. You rewrite that. All right. Okay, so let's do one with negatives now. Is that example 5? Find the antiderivative of, let's do negative 3x to the 4 with respect to dx. Actually, to the negative 4. Let's make them both negative. So, here we go. N is negative 4, so n plus 1, be careful, is negative 3, which is what I care about. So I have 1 over negative 3, negative 3x to the negative 3. Lots of negative 3's. Now let's do some simplifying. I have 1 over negative 3. Negative 3 over 1. X to the negative 3. All being multiplied. Which simplifies to negative 3 over negative 3 times x to the negative 3, which simplifies to 1x to the negative 3, which simplifies again to x to the negative 3. Last time to simplify. The IB exam hates negative exponents, so you're going to move it downstairs. You're going to, there it goes. You're going to move it downstairs to keep, right, to keep the exponents positive. And so your final answer in the most simplified acceptable form is 1 over x to the 3. Oh my god. Let me get my highlighter. There we go. Highlight. That's your answer right there. Oh, oops. Okay. I think let's do one last one, and then you guys will be fine. Actually, no, let's do 2 more. I have a... What is this? Example 6. So let's do... find the antiderivative of 20 with respect to dx. So we're finding the antiderivative of a number now. So I'm going to show you the long way, and then I'm going to show you the short way. Just to kind of, prove that There is a method to every shortcut that exists in math, all right? So, same exact process. 20 is just a number, but it can be easily thought of as 20 times x to the 0. Because if you remember, anything to the 0 power equals 1, even x. So x to the 0 power is equal to 1, right? So we really haven't changed the problem. We're just kind of thinking outside the box. All right? So let's move forward. And so now that I see it, like now that I can visualize an exponent, I can now use the formula, right? So right now n is 0, and then n plus 1, 0 plus 1 is 1, right? That's what we've been doing. Okay, and so my new using the formula, right? Remember, this is our formula. So using the formula, I have 1 over 1 times x. I'm sorry, forgot the 20. 20 times x. It's my new exponent. My new exponent is 1. So now let's do some simplification because I can't stand how busy that looks. Okay, let's simplify. So 1 divided by 1 is 1, right? This is so redundant. Like, people don't write that out. 1 divided by 1 is 1, and anything times 1 is itself. So we've simplified to this. But we can simplify even further. We don't even need to write that 1. It should be invisible, honestly. And so this is your final answer, 20x. No exponent, no 1s in the front. So now look from top to bottom. The only thing, let me get my highlighter. This is your answer. All right, look at the original question. This is your original question. The derivative of a number, the antiderivative of a number is always just attach a single x. Just attach a single x to that number, and you're done. Like, you can go the long way, but if you understand the long way, there's no need to go the long way every single time. Take the shortcut. I just don't want you, doing things because I told you that this shortcut works. I want you to know why the shortcut works. All right. Let's do one last one. Example 7. Okay, find the integral of 4x to the 7th. Stylus is dying. Plus 6x to the negative 3 minus 1 over 3 x to the negative 5 plus 2 dx. All right, it's combining everything we've just talked about. Okay, let's get to doing this. And so the way to approach these is you just do them individually, right? Let me do different colors. Right. Oops. You do them all individually. We're going to do 4 sets of antiderivatives. So the first one is 4x to the 7th. Well, they're all with respect to x. So if you want, I recommend pausing the video, solving this one on your own, and then starting it back up when you think you have the answer. And then we'll see if our answers are correct. If you got the same answer that I got. All right, so here we go. For x to the 8th simplified that's the red one. So what does that say? 6x to the negative 3. All right. One over negative 2. 6x to the negative 2, because we're adding 1, right, to the exponent. So let's go to the next page. So what does it say? 1 over negative 2. Oops. 6x to the negative 2, so that's 6 over negative 2, x to the negative 2. So that's negative 3, x to the negative 2. But keep the exponents positive. All right, that's part 2. It's part 3. Negative 1 over 3. What's that in blue? Negative 1 over 3. Too many page. We're doing part by part. X to the negative, is it negative 5? Yeah. All right, so it's negative 1 over 3. Actually, let me switch those. I don't want to mess you guys up. So it's 1 over negative 4, right? That's the one. That's the part that's, the formula. And then this function, x to the negative 4. So that comes out to negative 1 over negative 12, x to the negative 4, but that can be simplified. So 1 over 12, x to the negative 4, which is simplified again. Oops. 1 over 12, x to the positive 4. Okay, and then last one, 2. A simple one. Let me go ahead and add integrals to all of those. Okay. zoom in. Okay, so your final answer, put it all together, is, I'm just going to say it, x to the 8th, I'm going to highlight it actually. X to the 8th over 2 minus 3 over x squared. Ooh, you can barely see that. Plus 1 over x, 1 over 12 x to the 4th. So in this one, they're all in the denominator. And then last but not least, plus 2x. That is your final answer. Okay, that's all just one line. And so 4 pieces to that. Let me rewrite that because that's not okay. Okay, and then that's it, guys. So, thank you for watching, and try your best with these. We're gonna focus on. We're gonna keep doing these until you're very comfortable with them, and that's it. That's it, guys. The problems are due Sunday night at 11:59, and just text me if you need anything, or the class group chat or whatever. But thank you for watching, and I will hopefully see you guys later. Bye.